Hello everyone, today we're going to be talking about compound inequalities. So there are two types of compound inequalities. We have OR statements and we have where x is going to be between two numbers. So for example, we have x is less than 2 or x is greater than 5. And now the second type of compound inequality is where x is going to be between two numbers. For example, here x is between 2 and 5, where x is greater than 2 but also less than 5. So let's work on some examples in order to help our understanding a bit. So here we have -2 is less than or equal to x plus 3, which is less than or equal to 4. Remember that in order to graph an inequality, x has to be completely alone. So we need to isolate x before we continue. So the first thing we're going to do is remember that we always want to separate our equations. Whenever you see a symbol, an inequality symbol or an equal sign, you always want to draw a line to tell you what are the sides of my equations. So in this case, we have two different sides. So whatever we do on one side, remember that we always do to the other. But in this case, since we have two other sides, you have to do it to both sides. And you'll see what I mean now. Here, in order to isolate x, I need to subtract 3 because it's being added. So I'm going to subtract 3. And what you do on one side, you always have to do to the other. So since I have a side over here and a side over here, so I need to subtract 3 from both those sides. So I do -2 minus 3, which is -5, less than or equal to x, less than or equal to 4 minus 3, which is just 1. And that's it. This is our compound inequality, where x is in between -5 and 1. And we're going to follow the same rules of our open and closed circles, where basically here we see an less than or equal to, so we're going to have a filled circle. And here we have another less than or equal to, so we're going to have another filled circle. So I'm going to put those two closed circles on my numbers. So here -5 is on my number line, so let's just extend this number line really quickly. And then I'm going to add that closed circle over -5. And I'm going to add my other closed circle at 1. So I need to look at where x is. Here, x is greater than -5 because that little sign is facing x. So x is greater than -5, which means that we have to face our arrow towards anything that is greater than -5, which is this way. So I'm going to draw a line that goes towards the right, that goes towards those numbers that are greater than -5, like that. But I'm stopped here at this 1. My second rule is that x has to be less than 1, which means that I am going to draw a line going this way, because x has to be also less than 1, which basically tells me that x has to be anywhere between 5 and 1. So basically any of these numbers. So really my line would just go between -5 and 1, like that. Here, we're going to follow the same steps. We have 1 is less than 2x minus 5, less than or equal to 9. So let's draw our lines where our symbols are. And we're going to follow the same steps as we always do. SAD, MEP. So I'm going to add 5. Remember that what I do on one side, I do to the other. And I'm going to do to every side. So I'm going to add 5 here, add 5 here, and I get 6 is less than 2x less than or equal to 14. And then I'm going to simply divide by 2 on every single side again. And I'm going to get 3 is less than x, which is less than or equal to 7. So before I do anything, let's just add a 7 right here. Here I'm going to have an open circle, and here I'm going to have a closed circle. So I'm going to draw an open circle at 3, and then I'm going to draw a closed circle at 7. So I know x has to be greater than 3, which is anywhere this way. But I also know x has to be less than 7, which is this way. So that means that x has to be anywhere in between 3 and 7. So it'll be anywhere in this area right here. So that's would be my answer. So now take a moment and pause the video and try this problem out. And when you're ready, unpause the video and let's work on it together. So let's split our sides. And the first thing I want to do is I want to distribute. Whenever you see parentheses, you always have to distribute first, but everything else stays the same. So we're going to rewrite negative 6 is less than or equal to 3 times x is just 3x. 3 times negative 2 gives us negative 6, which is less than 12. And now we're going to apply the same sad method. I'm going to add 6 to every single side. Negative 6 plus 6 is 0, less than or equal to 3x, less than 18. And now the last step is to just divide by 3 again on every single side. And I get 0 is less than or equal to x, which is less than or equal to 6. So again, I'm just going to add 6 to my number line. So here I have two closed circles. So I'm going to draw a closed circle at 0. And then I'm going to draw a closed circle over here at this 6. And then, let's see, x has to be greater than 0. So it's going to go this way. And then x also has to be less than 6. So it has to go this way, which means that my area is going to be anywhere here between 0 and 6. And that's it. Now let's take a look at the second type of compound inequality, which is our OR statements. Whenever we see an OR, we know that we are working with two separate inequalities. So I'm going to simply solve each one individually, and they are each their own inequality. So I'm just going to simply solve this one first, where I'm going to add 4 on both sides. I get x is less than 2, and that's it. Now I'm going to solve the second one separately. I'm going to do minus 1 on both sides, where I get x is greater than or equal to 4. And now let's just plot them like normal. This is an open circle. This is a closed circle. So I'm going to place an open circle at 2, and x has to be less than 2. So I'll plot this going this way. And then x has to be greater than or equal to 4. So I'm going to plot it this way. I'm going to put a closed circle. And x has to be greater than, so I'll put it facing that way. And that's it. Notice how x is going in two separate directions. That's because x could be either or. It could be either one of those possibilities. So let's do another example. Remember, OR separates our two equations, and we're going to solve them individually. So here, the first thing I'm going to do is I'm going to divide by 2. And I get x is less than or equal to negative 3. And that's it. And now let's just solve the second one using SAD MEP. I'm going to first add 1 on each side, and I get 3x is greater than 9. And then I'm going to divide both sides by 3, and I get x is greater than 3. And that's it. So let's plot them. This is going to be a closed circle, and this is going to be an open circle. Let's place a closed circle at negative 3, and then an open circle at 3. So now x has to be less than or equal to negative 3. So since it's less than, we're going to put it facing this way. And here, or x has to be greater than 3. So we will place it going this way, because that way is greater than. And that's it. So try this last problem, and when you're ready, unpause the video and let's work on it together. Remember that these are two separate equations because it has an OR, so let's solve them individually. Let's place our lines. Here we're going to first distribute. Remember, whenever you see parentheses, the first thing you want to do is to distribute. So we're going to get negative 2x minus 6 is greater than 4. And then we're still going to follow SAD MEP. Here I'm going to add 6 on both sides, and I get negative 2x is greater than 10. Here I'm going to divide by negative 2. But remember, what happens when we divide by negative? That's right, the sign flips. So we're going to put x is less than negative 5. So it is no longer greater than, it is now less than. Now for the second inequality, I'm going to just simply add 5 on both sides, and I get x is less than or equal to 4. Here I'm going to have an open circle. Here I'm going to have a closed circle. Let's place an open circle at negative 5. Let's just add that negative 5 here. We're going to have an open circle there. And then we're going to place a closed circle at 4 right here. X, x has to be less than negative 5, which means we're going to put it facing that way. Or x has to be less than negative 4. So we will place a line going this way. But that will stop at negative 5 because since x cannot equal negative 5 because it is simply less than, we are going to stop our line right there, and then it will just continue after negative 5. And that's